Hello everyone, my name is Ye. I'm a research scientist at NVIDIA. Today I will present our work, GLAMR, Global Occlusion Aware Human Mesh Recovery with Dynamic Cameras. The task we focus on is Global Occlusion Aware Human Mesh Recovery, where the goal is to estimate the pose and shape of people in a consistent global coordinate system from videos captured by dynamic cameras. We also want to estimate the pose of invisible people when they are occluded. Just like in this video, the two actors are going in and out of the field of view, but we still want to estimate their pose and global trajectories even when they are invisible. Our motivation is that, first, many videos in sports, movies, and our daily life are captured by dynamic cameras. Second, reconstructing pose in a global coordinate system can enable many applications in AR, VR, animation, sports, and so on. Also, occlusions are a big problem in pose estimation, especially when people are completely occluded. There are many problems with standard human pose estimation methods when applied to this task. First, estimating the absolute depth of the humans is quite difficult, and even state-of-the-art methods can output jittery or wrong depths as shown in the video. Second, most methods only estimate pose in the camera coordinate, or sometimes only the root-centered coordinate, so they cannot estimate global human pose from dynamic cameras, as the pose they estimate is not registered in a consistent global coordinate system. Additionally, they also fail to handle severe and long-term occlusions where there are no bounding box of a person for a long period of time. To address all these issues, we propose a new approach called GLAMR that learns to hallucinate invisible human motion from visible data using deep generative models. Given a video from dynamic cameras, we first use multi-object tracking and re-ID algorithms to obtain the bounding box sequence of each person in the video. We then apply 3D human pose and shape estimator to obtain the motion of each person, which consists of the shape and 3D pose sequence in the camera coordinates. The motion can have occlusions where poses for some frames are missing because the person is occluded in the video. In the next stage, we propose to learn a generative motion filler to hallucinate occluded body motions to obtain occlusion-free body motions. Next, we propose to learn a global trajectory predictor that infers the global root translations and rotations of each person from their local body movements. Finally, we propose a global optimization framework that jointly refines the global trajectory of each person to match the video evidence such as 2D key points. Now we show the results of our approach GLAMR and the baselines for a demo video. We can see that GLAMR produces smooth and accurate human motions in a consistent global coordinate system. GLAMR also hallucinates more natural motions for occluded humans, which are rendered in transparent colors. Here are more results on the 3DPW dataset. In the input video, the bounding boxes are used to indicate whether a person is detected and visible. Again, we can see that GLAMR can estimate more smooth and accurate global motions and infer more natural human motions for occluded humans. In conclusion, GLAMR marks a significant initial step towards global human mesh recovery in the wild. An important takeaway is that generative motion models can help overcome occlusions and let us see what's invisible. Furthermore, GLAMR has many future extensions such as combining the scene information or reasoning about the interaction between people. For more information and the code of the paper, please check out the project website.